Hello guys, and how is it going?
I have 3.
Okay, the ad is playing for me, so it seems like it is started. Guys, so sorry first of all for all the delays that we had in this stream. So many things happened. This broke a record on how many times it was postponed, and I hope that it didn't make it so hard for you guys, but thankfully we finally are having this stream, and it is gonna be awesome for you because as I told you in the Telegram channel, this stream we're gonna solve 2000 difficulty problems in a way that everyone could understand. It doesn't matter that what is your rating right now, you will definitely be able to understand this. And I guess by now almost all of you are in our Telegram channel, but if anyone is not, you can join our Telegram channel by the link that is in our descriptions below. Let me share my screen. And as you see guys, a bit our background, I changed our background a little bit. I guess that this way it would be better for you guys. So the link to the Telegram channel is here. You can find it here, and our votes for choosing the topic stream will be in this Telegram channel in general. Okay, so are you guys ready to start? I saw some good comments, some funny comments. Prosha never fails to postpone the stream. Yeah, I accept that this time it was really not good. Looks like it will start someone eternity later. Yeah. I can share do you want all the problem links right now? Yes, I can. If you want, I can share all the problem links right now too. These are the links to the problems that we're gonna discuss today. All of them are difficulty 2000. And we are gonna solve them all today. And it's gonna be super easy for everyone. I mean, I'm pretty sure that everyone will understand this. And yes, guys, if you want to, it's too soon to ask that because you don't know how this stream will go on. But anyway, if you want to support the work, you can like this thing. And I see that 23 people have liked it so far. And guys, thank you very much for your support. Even though you haven't even seen what the stream is so far, the fact that you have liked it, it means a lot. Your support means a lot. I'm pretty sure you will like it. Okay, so without more further ado, let's start talking about our stream today. And guys, I saw that there's Codeforces Blitz Cup as well. It seems interesting. I haven't followed them yet, but it seems very interesting. Are you guys following them? I just said without more further ado, but I just made further ado. Yeah, especially tourists versus conquer of tourists. I'm fan of Kobe. If you remember, I had an interview with Kobe in this channel as well. He won the first round. I hope that, I had the interview with Kobe here. I hope that he will win against even tourists. Okay. Yes. So let's start the stream and start talking about the problems that we want to discuss today. Okay guys, the first problem, as I sent the link to you guys too, which says, can I work to improve my DP? I will talk about that at the end of our topic stream. Yeah. So the first problem, guys, it says that the first problem is 487b. As I sent the link to you guys, strip. It says that Alexandra has a paper strip with n numbers on it. Let's call them AI from left to right. Now Alexandra wants to split it into some pieces, possibly one, such that for each piece of the strip, it must satisfy the following. Each piece should contain at least L numbers, and the difference between the maximal and the minimum number on the piece should be at most S. You have to find that what is the minimum number of pieces that we can have such that it meets the condition above. So let me explain on tablet as well. That's what does it saying. It says that we have three numbers n, s, and l, and we have an array a1, a2 to an. This problem, by the way, has difficulty 2000, like all the other problems that we're gonna discuss. It says that we wanna split it into several parts, into several continuous parts, such that in each part, first of all, the length is at least L, and second, max minus mean the maximum in that, minus the minimum in that interval will be at most the value S. So the length must be at least L, and the maximum minus minimum must be at most S. You have to say that what is the minimum number of pieces that we can make, such that all the pieces have these conditions. Okay, is the statement clear? If anyone is not comfortable with this statement, let me know so that I repeat the problem statement. N is up to 10 to the 5th, S up to 10 to the 9th, and L up to 10 to the 5th. Okay, nice. So we want to solve this problem. Let's think together that how a problem like this can be solved. Please repeat once again. Sure. I'm saying that assume that we have the values N, S, and L, and the sequence A1, A2 to AN. We want to split it into several intervals such that each interval, its length is at least L, and the value, the maximum value minus the minimum value is at most S. You have to say that what is the minimum number of intervals that you can split your sequence into, such that it has the following conditions. Each interval must have length at least L, and the maximum minus minimum must be at most S. Is it clear now? So let's see that what can we do. Guys, if we want to define a DP on this problem, what do you think is a good definition for DP? Nice. It is necessary to pick all the indices, yes. We want to split the whole array. So we have to pick all the, we want to split it into several parts. And that's what we want. We want to split our sequence into several parts. So all of them must be picked. What do you think, how do we define a DP on this problem? Let's just start with the definition of DP. I mean, as the ideas that we have explored so far, if you have watched the previous dynamic programming topic streams, or you have solved DP problems before, you have some intuition. So how can DP be defined on this problem? Are there any suggestions? Should it be one-dimensional, two-dimensional, or what? Blue background, please. Okay. I chose a dark background for this one, but if you want, in the next ones we can change it. Previously it was all light, now it's dark. dp of L and R, answer of the segment, dp of I, minimum number of answer for a prefix. Yes, it seems good. Why L and R might not be possible? Because the value of n is up to 10 to the 5th. This gives us an intuition that maybe our dp cannot be two-dimensional. Because if it's two-dimensional, it would be too huge when n is up to 10 to the 5th. So it gives us the intuition that if we do dp, it must be one-dimensional. And the problem really looks like a dp problem as well. I mean, we can think about, instead of solving the whole problem, solving a problem for the whole sequence, we can solve it for any prefix, for every prefix. So I'm saying that we can define dp of I as the answer if we only consider a1 to ai. If we only consider a1, a2 to ai, what is the answer? Why this is helpful? It's helpful because if this way, if we just choose that what is the last interval that we have, for example, assume that the last interval is from aj to ai, then the rest of the problem recursively is gonna be dp of j minus 1. So that's how dp can be helpful for us. If we solve the problem for any prefix, because each time we are choosing an interval from the end and remove it and say that, okay, this is one of our intervals, the rest of the problem can be solved using dp of j minus 1. So dp helps itself to be calculated this way. That's how dp works in general. As we have seen previously, in dynamic programming, we define so many subproblems instead of just having one problem. We define so many subproblems such that these subproblems help each other to be solved. In here, we see that if we have dp of each prefix, these prefixes can help each other to be solved, and they help to build the answer of each other. And this way, at the end, our final answer is going to be dp of n. Once we have the value of dp of n, the problem is solved. That's the real solution to that's the final answer to the problem. So now, how can we find out that what is the optimal j? We just need this. We just need to find out that what is the optimal j for each I. For each I. I have to find the optimal j such that the interval from a sub j to a sub I is a valid interval. It means that its length must be at least L and the maximum minus minimum must be at most S, such that the aj to ai, this interval from aj to ai is a valid interval. We have to find the optimal j, and if we do that, dp of I will be updated by dp of I. That way will be equal to what? Can you say that? If we find that what is the optimal j such that a sub j to a sub I is our last interval, can you say that what dp of I will be equal to? You know what? I tried to solve it myself by the time he solved it. That's a good challenge. It starts. That's a good goal. Exactly, dp of j plus 1. Because we said that the last interval is from aj to ai, and it will be, that's a dp of j plus 1. Exactly. So now we have to just find out the optimal j. It means that for all the valid j's, for all the j's, such that aj to ai is a valid interval, for all of them, for all such j's, we have to find out that what is their minimum DP. If we find out the minimum DP of them, to be more precise, is DP of j minus 1. Sorry, DP of j minus 1, not DP of j itself. J minus 1, because aj to ai is the last interval, and now a1 to aj minus 1 is left. So now I have to find out for all the valid j's what is the minimum value of DP of. I should have some intuition about, okay, so what are the valid j's that I might have? Sorry that I'm not going straight forward. I have to find out what are those valid j's, and I should have some intuition about how do they look like, and that would help me to find out what is their minimum value. So what I say is this: if you consider the ith element, if you consider the element number I know that j must be in a way that this interval from j to I is at least, its length is at least L. So j must be at least I minus L plus 1. J must be at most I minus L plus 1. It cannot be after that. Okay, because that's the first element, such that its length is this much. If j will be anywhere here, it won't work, because the length of the last interval this way would be less than L. And also j must be in a way that this interval, its maximum minus minimum, is not more than s, is less than or equal to s. Consider the first time that it gets greater than s. Assume that we start from I and we go backward. Consider the first time that maximum minus minimum is greater than s. Do you agree that from there, all of these indices, for all of them, maximum minus minimum is gonna be greater than s? If I start from here, I know that maximum minus minimum is gonna be greater than s. So if I start from anywhere from here, still maximum minus minimum is gonna be greater than s. So the first time that maximum minus minimum gets greater than s, it will remain greater than s. It will never get less than s again. So it's gonna be, the possible values of j will form a continuous interval. There will be a continuous interval such that if j will be in this interval, this interval, if j is in this interval, the interval that starts from j and ends at I is gonna be a valid interval. So I'm saying that for each I, the valid j's form an interval. There's an interval of elements such that j is valid there. Do you guys agree with this so far? So I'm saying that the valid j's will form an interval. If you agree with that, please use this emoji 100 emoji or put a plus in the chat. Or if you did not understand, put a minus or just tell me to explain it again. So I'm saying that basically what I'm saying is that when you fix the value of I, the valid j's will form an interval. There's an interval that if j starts from there, this segment that we have from j to I will be a valid segment. Okay, I will explain it again. I'm saying that as soon as we have fixed I, we want to see that which j's are valid. In other words, the interval that starts from aj and goes to ai, it will be a valid interval. Okay, I'm saying that first of all, j must be in a way that the length of this segment would be at least L. So j must be less than or equal to I minus L plus 1. Otherwise, if j is greater than I minus L plus 1, the interval from j to I will have length less than L. So j must be less than or equal to I minus L plus 1. On the other hand, j must be in a way that maximum minus minimum is less than or equal to s. If j is to the left of the first place that max minus min gets greater than s, consider the first place that max minus mean is gonna be greater than S. Anywhere to the left of it, still max minus mean is gonna be greater than S as well, because mean only gets less than what it is right now, and max will only get more than what it is right now. So its difference will increase, it will not decrease. So the first time that max minus mean is greater than S, if you move J forward, if you move J leftward, it will remain greater than S, because max only increases and mean only decreases. So it will remain greater than S. So what I mean is that these ones are not valid, and these ones are not valid too. So the J's, the values of J which are valid, they are all in an interval. So there will be an interval such that if J is in this interval, this segment that it makes will be a valid segment. Okay, yes, the difference will not decrease as we move J leftward. Is it clear now? Yes, and among all of these J's, we should find the J such that dp of J minus 1 is minimum. And then we add 1 to that, and that will be our dp of I. So my idea is something like this. My idea is to just try to keep a set. My idea is to just try to keep a set, and in that set, keep all the dp's in this interval. Okay, I want to keep the dp's of the indices that are in the interval. For all j in this interval, I will insert dp of j minus 1 into this set. And if I insert that, at the end, I can just see that what is set at begin, and set at begin is going to be the minimum of them. So, or I can say multiset. Let's say multiset, because we can have the same value for different j's. Okay, a multiset. So I mean that we can have duplicated values as well. By multiset, I mean that we can have duplicated values as well. We can have 2 3s, for example. So I just want to keep dp of j minus 1s in a set. What I do is this: assume that I'm at position I, and so far I have this interval. I'm at position I, or let's say I was at position I minus 1, and I had the interval for I minus 1, and all of them were in a set. My idea in here is somehow similar to 2-pointer. The point is that when I increase I and I go to index number I, what I do is this: I will see that what is the leftmost element. I mean, I will consider this. I mean, we have 2 pointers here, P1 and P2. These 2 pointers show the interval of the valid j's. Okay. Assume that all of the values of the numbers that we have from P1 to I, they are also in a set. I can say that as long as the value of the maximum value minus minimum value in that set, their difference, maximum minus minimum, is greater than S, I have to move P1 forward. So let me write it as assume that we have A of P1 to A of I minus 1 so far in a set. Now when I increase I, when I come to I will insert A of I into my set as well. And then I will have a while maximum minus minimum in that set was greater than S, I will move P1 forward, and I will erase A of P1 from my set. I will first erase, I say that st that erase A of P1 and then P1 plus plus. Okay, it's a pseudocode basically. While the maximum in that set minus the minimum in that set was greater than S, it means that I have to move P1 forward. So I will do that. And at some point P1 stops. And also for P2, I have to increase P2, I should move P2 forward as well. Because now I has increased by 1, so I minus L plus 1 is increased by 1 too. So P2 will move forward as well. And if P2, if the interval was non-empty, because it's also possible that in a rare case, it's possible that P1 will go even further than P2, will go to the right of P2. In that case, when you move P2 forward, still your interval is empty. If it was not empty, you will add this one to your sets of DPs. So basically, when you erase some value, you will both erase its value from this set and also you will erase its DP from the other sets that you kept the values of DPs. Okay, so basically the idea is this. I have an interval that I said that, okay, this interval is the interval of valid J's. Assume that for I minus 1, I calculated this interval. Now I say that when for I minus 1, I have that, for I can easily have that as well. The point is that first, I will move the left pointer forward as much as I have to, because I can see the values in the sets. I can see that what is the maximum value in the set and what is the minimum value in the set. They are big enough the set and are big enough the set. I can see the minimum and maximum in the set. As long as the difference was greater than S, I will move the left pointer forward. And also I will move the right pointer forward as well. This way my interval will be updated and I can add and erase elements from my sets. Also in the sets of DPs, I will insert the corresponding DP. And this way I can have all the valid DPs and I can easily find out that what is its minimum. I have all the DPs in a set. I will get their minimum. I add 1 to it and set that as DP of I. Is the idea clear? Is what I said clear? If it is, please put a plus or use this emoji. If not, let me know. Yes, P2 just gets increased by 1. Can you also show recursive DP solution, as it is a bit easy to study? Basically, what we are doing is doing it recursively. But okay, I will show you the code as well. Let me talk more about it when I'm showing the code. Yeah, but that is really hard to implement. Segmentary is a lot more easier. No, you don't need segmentary, and no, it's really easy to implement. I will show you the code. I will show you the code. So if it's clear, please let me know. If not, also let me know to explain it again. If it's clear, I will show you the code as well. So everyone understood it completely. So guys, the main idea was this: the valid J's. This is one of the ideas that is used in DP. When you want to find out from which DPs DP of I can be updated from, sometimes they form an interval. And the point is that with 2-pointer you can move that interval as interval of valid J's, and you can update all of them in your sets. And this way you can easily find out what is the minimum of them, and you can keep the minimum and only add 1 for it to it. Okay, I can come up with the recursive approach. Yes, the only way to improve in it is to solve more and more problems and implement them. It's very common. I mean, this happens for so many people. I strongly recommend to you to implement all the problems that I discuss here. Guys, I recommend to all of you, try to implement all of the problems that we're discussing in here, because if you only hear the solution, it's not enough. You have to also implement them. If you want, in our Codeforces group, I will add all these problems such that you will solve all of them. I mean, you can go there, and whenever you solve the problem, you can accept it there. And we can see that how many of you have solved all of them. Okay, we will do that. Python, I think Python also has ordered set. But if you want, we can show you a Python code as well. Where is the Codeforces group? The Codeforces group's link is here as well. The link to the Codeforces group. It's in the description. I usually put a context before each stream so that you can think about the problems before the stream, and then I solve them in the stream. Today we didn't have that, unfortunately, but I will add the problems to a contest here so that, and keep it open forever, such that you can accept the problems there. And try to accept all of them, really. It's super helpful if you can also accept the problems, not only hear the solutions, but also accept the problems as well. When you accept them, in future, when you see similar problems, you can easily solve them. Let me also show you a code for this problem as well. Because it's, as I said, it's super easy to implement. Maybe let me make it full screen. That's it. I mean, all of it is this. So basically, it has a for I from 1 to n seen AI. It gets AI. That's it. And in here, we have a for. First, he inserts AI in set S. He inserts AI in the set S. Set S contains all the values. And it's a multi-set such that it can store duplicated values as well. The normal set has only one of each value. So if, for example, in a set, if in a set you already have value of 3, if you insert 3 again, nothing will change. But if you have a multi-set, if you insert 3 again, another 3 will be added. So it can have duplicated values. So that's why he kept multi-sets, such that he can have duplicated values as well. And what he does is this. He says that while s.size was non-zero and the value of the maximum, s.rbegin is the maximum value. This star s.rbegin is the maximum value. Minus s.begin, if while this difference was greater than a diff, he will erase, first he will erase this value. I mean, CNT in his code is the left pointer. He will erase the left pointer from S, the value of the left pointer from S, and he will say that if I minus CNT was greater or equal to len. Why does he say that if I minus CNT was greater or equal to len? Because if it's not, this value is not in the set R. Set R contains all the DPs. Set R contains all the DPs. Set S contains all the values. All the values. So basically what he's doing is this. He says that if I minus CNT was greater or equal to len, if it was less than len, it is not in set R. He says that if it is already, if I have stored it in set R, he will insert it, he will erase it, he will erase dp of CNT minus 1, and then he will move this CNT forward, he will move this pointer forward. And then he says that if I minus CNT plus 1 was greater or equal to len, he wants to add another element to set R. He says that if I minus CNT plus 1 was greater or equal to len. Why does he say that? Because if I minus CNT was not, I minus CNT plus 1 was not greater than or equal to len, it means that it's like in our solution, P2 is to the right of P1. Or in other words, this one is not valid anymore. Our pointer, our CNT has moved to the right of it. It means that our CNT has moved to the right of it, so this one is not valid anymore. Basically, it's checking that if CNT is in a position such that its difference with I is at least len, in that case, he will insert dp of I minus len as well. Otherwise, I minus len is not valid because it's before CNT. So if I minus len was after CNT, it means that if it was still valid, he will insert it in set R. And then if R dot size was non-zero, dp of I will be R dot begin plus 1. r dot begin is the minimum value of dp, and dp of I will be r dot begin plus 1. Otherwise, dp of I will be nth. It means that there's no way. So if there's no way, we just conventionally write nth there. And at the end, if dp of n was greater than or equal to nth, it means that we have no way, so the answer is -1 as the problem wants. Otherwise, the answer will be dp of n. And that's all. That's how this problem can be implemented. Is it clear, guys? If the code is clear as well, please again use this emoji or put a plus. Yes, I think a pupil, yes, definitely, a pupil should learn DP as well. And as I said, these 2000 rated problems are in a way that even if you are a newbie, you can understand. Right now in the chat, you can say that. If you are a newbie and you are understanding it, I want you to say that in the chat. I want to make sure that we are in the right track. Okay, so if you are not understanding anything, let me know to explain it again. It's completely okay, guys. I can explain it again if any part is not clear. But I strongly believe that you can all understand it. Great. Awesome. So, I'm new to learning DSA. I recommend you to watch the topic streams in the order that they are currently in the topic streams. Start them from the beginning. Also, you can watch the guideline videos that I had, like how to get to expert and how to get out of newbie. You can come to the channel, and in the guideline videos, you can just watch these videos. One of them is from newbie to expert in 3 months. One of them is never do this if you want to get out of newbie, and also the other one that is that instead do this if you want to get out of newbie. I really recommend these 3 videos. I once talked to you about how to grow in Codeforces when you start in these videos. If I want to talk again, I will just repeat the words that I said here. So I recommend you to just watch these videos. Python code, please. Okay. I feel I need to rewatch the video. Okay, sure. Also, if any parts do you think it helps, if I explain it again, let me know. Ifs are not clear, okay, I explain them again. So, guys, basically this if says that if I minus CNT plus 1 was greater than or equal to len. Why do we have this if? Because if this if is not true, it means that CNT is in a position, CNT is the leftmost place that J can be. If I minus CNT plus 1 is not greater than or equal to len, it means that it's less than len. So in this case, there's no valid J for I. If I minus CNT plus 1 is less than len, it means that there's no valid J for I. So you should not insert anything for I. But if it was, there is at least one. So also I minus len is always the rightmost element of this interval. So you have to insert I minus len as well. So this is the first if. As I said, when you move the right pointer forward, you have to insert one element to your set. But not if there are no J's possible for this I. And then you say that if r dot size was non-zero, dp of I will be r dot begin plus 1. Is it clear now? What is acting as P2 pointer in our whiteboard approach? P2 is exactly I minus len. P2 is always equal to I minus len. In here, when you see that we have r dot insert I minus len, you know that always the rightmost possible J is I minus len. But only in the case where I minus CNT plus 1 was less than len, it means that we have no valid J, so nothing must be inserted. Is it clear? We are a bit behind our schedule. Very soon we have to start the next problem. I estimated 30 minutes for each problem. Yes, yes. The maximum value in a set is RBG. Nice. So shall we move on to the next problem? If you want, let me send a link to a Python code as well, so that you guys, because you asked for a Python code as well, you can see that too. I see that people haven't implemented with Python in the first page at least. Let me search for Python. There are too few people who have used Python on this problem, and their code is super long. I'll send one of them to you. And also, guys, let me tell you that this problem could also be solved using queues. But because set was simpler on this problem, I explained it with set. If you want to join a Python, if you want to see a Python code, you can see that. But for hard problems, usually in CP we use C++. So I highly recommend to you to use C++ instead on these problems. For the first problems in a contest, it's okay to use Python. But when problems get harder than something and some threshold, it's better if you use C++. So if you are so far using Python, if you want to become a professional in competitive programming, I highly recommend to you to start learning and coding with C++. Why is it needed to delete dp of cnt-1 from R? Because cnt is moving forward, so it's not a valid point anymore. So dp of cnt-1 must not be in our set anymore. In the set of R, we store all the valid dp's, all the dp's that we can add 1 to them and set them as dp of I. When cnt is moving forward, cnt is not a valid j anymore. So dp of cnt-1 must be deleted. It's not one of those dpj-1s that could be, when cnt cannot be a j anymore. Okay, so in set R, we want to keep dp of cnt-1 for all the valid j's. That's why. Yes, that's right. Although Python can be used in the first problems on the contest, sometimes it's even easier to use Python, because Python can be used and you can write a shorter code using Python if you use it instead of C++. So sometimes in some of the first problems, people use Python. But in the harder problems, usually people start using C++. dp of I will always be more than dp of cnt-1. Yes, but it cannot be updated from that. If we keep dp of cnt-1, we might set dp of I as dp of cnt-1 plus 1. But maybe it cannot be that. Maybe it should be more than that. Okay, so if you keep dp of I in dp of cnt-1, if you keep dp of cnt-1 in your set, you will update dp of I from dp of cnt-1, but you cannot do that. So it's not helpful. Which math book is best for competitive programming? In the first dynamic programming live stream, I've added some math books because people asked about it. If you open the first dynamic programming topic stream, I've added some books that if you want, maybe you can see them. And for the math books, I highly recommend Mathematical Seekers Russian Experience. That's very helpful. Okay, so now let's move on to the next problem. The next problem is also a very good problem. We are a bit behind our schedule, but it's okay, we can fix it, hopefully. Okay, Mathematical Circle Russian Experience. This is the book. Okay, let's move on to the next problem, Lefko and array. This is the second problem. So this problem says that Levko has an array that consists of integers a1, a2 to an, but he doesn't like this array at all. Levko thinks that the beauty of the array a directly depends on the value ca, which is calculated by this formula. C of a is maximum of the difference between each two consecutive numbers. So C of a is the maximum differences that two consecutive numbers can have. The less value C of a is, the more beautiful the array is. And he wants to change at most k numbers such that C of a will be minimized. So basically this problem says that we have an array a1, we have an array a1, a2 to an. We want to change k, at most k of these elements, such that at the end the maximum value of the differences between consecutive numbers will be minimized. This maximum value will be minimized. Okay. We want to minimize this maximum value, and n and k are up to 2000. Okay, now this is a place that I can see that how many of you usually join the topic streams or the streams that we have in channel in general. Currently, I have said something very recently. I have said something to you that in these problems is super helpful. Can anyone say that? I said something in one of the streams that we talked about it. Maximize the minimum. No, we want to minimize the maximum. Usually, how many daily problems do you recommend to solving? I talked about that in the video as well. I mean, for more detail, I cannot go into details right now. See the how to get to expert video. Yeah, can you say that what exactly I said in a stream? I said something that if you have joined the stream, now you can see, you can feel the growth. You have some intuition already about this problem. If you usually attend the streams, I told you something that now you can feel the improvement. You can see that how better intuition you can have when you face some problems in Codeforces. Can anyone say that what exactly I said? Okay, what exactly I said in this stream? How many of you usually join the streams? See, this is where you can feel that how connected different problems are and why it's good to hear the solutions of different problems and how it helps to build the intuition for the other problems. Exactly, I said this. In the other stream, we faced with a problem such that we wanted to minimize the maximum value. And I said that usually in these problems that we want to minimize the maximum value, binary search works well. Why? Because when we want to minimize the maximum, if we do a binary search, for example, we say that, okay, I want to see if my answer can be at most D. Then it means that all of these values must be at most D. So when we want to minimize the maximum, it's good to do a binary search, for example, on some value D, and you want to see that if the answer can be at most D. If the answer is at most D, the condition will turn into, for each I, A sub I plus 1 minus AI must be at most D. So with the binary search, everything will get simpler. Instead of considering different numbers and now, okay, how should we calculate the maximum one of them, etc. Instead, we can say that, okay, let's do a binary search on the value D, and then we can say that the difference between each two numbers, or all of those values that we are taking the maximum of them, all of them must be at most D. So I repeat it once again here. Usually, I don't want you to just hear the solution of the problem. I want you to realize the concept behind it, because you see the same patterns so many times in different problems. For example, if you watched how I solved the other problem the other day in the other stream, Now you see that the same intuition helps on this problem as well. So I write it here. Usually when we want to minimize the maximum or maximize the minimum binary search works. Binary search basically destroys the problem. Also, if we want to maximize the minimum, also we can do a binary search and we can see that if our answer can be greater than or equal to D, then all of the values independently must be greater than or equal to D. Binary search is what makes these constraints independent. So instead of saying that let's calculate the maximum is dependent because it depends on what different values is. We can do a binary search and all of these conditions will be independent. Each of them individually must be less than or equal to D. Always or usually. You can never say always, because maybe some problems, we can define some problems that it will be solved in another problem. But usually it works like this. It's good to have this intuition that usually when we want to minimize, I can say it like 90% of times. 90% of times. When we want to minimize the maximum or maximize the minimum, binary search is the answer that can destroy the problem. And because it basically makes everything independent. When you do binary search, these differences, these conditions will be independent. Independently, each two numbers their difference must be less than or equal to D. No, right now I don't have any example for the other 10%, but I'm just saying that to be safe. We cannot basically say that always, I cannot say that always something happens, because it's possible to find a counterexample. It's possible to define a problem that will be solved in another way. But I can say that most of the times it's like this. So it's good to keep this in mind. When you want to minimize the maximum or maximize the minimum, it's good to have this intuition of doing a binary search. There are so many problems that we want to do this, and almost in all of them, binary search works. And as I said, if you have joined the other stream and you face this problem in a contest or something, to have this intuition that, okay, let's think about binary search. Yeah, yes, it works great. How many questions to learn DP? I didn't get what you mean. In general, or how many questions are we solving in this topic stream? I didn't get your question completely. So let's do a binary search on the value of D, and we want to see if the answer can be at most D. Now I should make the differences between each two consecutive numbers to be at most D. The difference between each two consecutive numbers must be at most D, right? So how can we do that? Well, the point is that there are some numbers that we change. There are we can change K numbers. Let's look at it in another way. When we can change K numbers, it means that we must keep n minus k numbers. N minus k numbers must be kept unchanged. N minus k numbers must be kept unchanged. That's for sure. Now let's consider all the numbers that will be kept. The DP that I will define on this problem is a bit different. Do you have any suggestion for example, what DP of I can be? Again, we can see that in this problem, the value of n and k are up to 2000. So the constants are very important to find out that how should we think about DP? When n and k are up to 2000, it means that we can either do a two-dimensional DP or a one-dimensional DP, but in order to update it, we can have a 4 on all the previous DPs as well, for example. So can you say that, do you have any suggestion for what DP of I is? Trying for math flashing DP lectures but couldn't solve problems. Did you accept the problems that are discussed in the topic? I don't know where, from the other sources, but about the topic streams themselves, have you accepted the problems as well? Because it's super important to also accept the problems. It's not enough to just listen, because after a while, even if you will be able to solve the problems, you will not be able to implement them. So it's not useful at all. I don't think there are so many greedy books about greedy. Again, for greedy, I also had topic streams for greedy algorithms. You can see that in the topic streams here. You can see all the topic streams here, and you can see that we have greedy algorithms there too. I recommend you, and it was only 2 weeks ago. I recommend you to watch that first. I do not recommend book for example, learning greedy. Just watch the topic streams and go on Codeforces first, implement this problem discussed in the topic streams, and then also solve other problems on Codeforces with that greedy, for example. Need good problem set, okay, sure. True if it's possible to keep the maximum difference standing while making at most k-1 change. Okay, so you say that, let's define it as a boolean that says that if it's possible to make the first I, okay. On changing k numbers, the minimum of max difference. No, I did a binary search. I just want my difference to be at most d. I know that the final answer must be at most d. I want to check if it's possible or not. Can you also define some number for it? Maybe boolean is not enough, because when you define it as boolean, you are saying that, okay, let's say we have at most k changes, but it's better if we keep that. What is the minimum number of changes for that? We can keep that. What is the minimum number of changes that we can have? What is the minimum number of changes that we can have such that we make the first I okay, the first I elements okay? Yeah, I responded it. I will. And thank you very much, Sankit. Thank you very much for that. I will, definitely. Which patterns are mostly repeated in greedy algorithms for Codeforces? Go watch the topic stream about greedy. I think that many of your questions will be answered there. And also, guys, each week I have a vote for the next topic stream in our Telegram channel. And you can watch the link to the Telegram channel here as well. Go there and you can vote on what topic you want to be discussed in the next topic stream. So for example, if you wanted to have another greedy session, we can have that. Elements we skip till I, exactly, that's a good number of elements to be changed. Exactly. Technical using convex optimization, I can do in the future. That's the next level. I can do that in the future. You're welcome. That's very good. Very good. So dp of I can be the minimum number of changes to make the answer at most d. Or in other words, the maximum number of elements to be kept, maximum number of elements to be kept unchanged such that the difference between each two consecutive is at most d. So let's say that, okay, so we are at index I. Let's say that this last one is I. I say that this is the maximum number of, I want to find out what is the maximum number of elements to be kept unchanged. So I want to fix that. What is the previous elements that is kept unchanged? I want to find out that what is the previous elements that I want to keep it unchanged. Let's say that it is element number j. Assume that no, and I assume that I will be kept unchanged as well. Considering that I is the last one. I is the last one. It doesn't make much changes, but it's make it easier. You can also not consider that. If you don't consider that, you can just simply say that, okay, if I is not in that, it will be dp of I minus 1. So both works. You can also assume that I will be kept unchanged to add that to your condition, or you cannot that. If you don't do that, the only change that it makes is that if I is not on one of them that is unchanged, your answer will be dp of I minus 1. Because I will be changed definitely, so it will not be one of them that will be unchanged. So the answer will be dp of I minus 1. Do you agree with this? So first of all, I can say that, okay, there are two cases. Let's say that there are two cases. I will be either changed or will be remained unchanged. If I will be remain unchanged, it will be dp of I minus 1. Can you do next contest proposal? What do you mean, the Codeforces contest, or do you mean in the group? Yes, so dp of I, if I will be changed, So I'm just saying that basically these two dp's do not differ a lot. You can consider each one of them. Even if you consider that I will be changed as well, it would be the same thing. So if I will not change, will not be kept the same, the answer will be dp of I minus 1. We say that in the first I minus 1, how many we can keep unchanged. And then we change I in a value that's such that it will be okay with I minus 1. Now assume that I will not change. I will be kept the same. Now let's say that I will be kept the same. Now we can fix that what is the last one that before I that was kept unchanged. If it is j, can you say that what is gonna be dp of I? If the last one before I that is not changed, if the last one before I that is not changed is j, what will be the value of dp of I? If the last one before I that is not changed is j, is dp of j. No. In our dp, we keep the maximum number of unchanged values. Exactly, dp of I will be dp of j plus 1. Because we say that, okay, if j is the last one, what is the number of them that will change? And then I will be added to that as well. Exactly. So now let's consider this. Let's define our dp because it makes everything clear. I just told you that how we can change between these two definitions of dp. It has a bit more detail, but it's easy to change this definition of dp. Let's say that to make things neater, I also add this condition to my dp as well. That also I is one of them. That will be kept unchanged. Or in other words, I is the last one that will be kept unchanged. Okay, so we want to see that what is the maximum number of elements to be kept unchanged such that I is the last one that is kept unchanged. Then everything will be neater because we are sure that j has remained unchanged, and we can just say that the previous one is j, so our dp of I will be dp of j plus 1. So for each j that can be kept unchanged, for each j such that it's possible to keep both I and j unchanged. For some of the values of j, it's not possible. We cannot keep both I and j unchanged. But for some of them, it is possible. For all of those j's that it is possible to also keep j unchanged, keep I and j both unchanged, we can say that dp of I max equal to dp of j plus 1. Can I say that what is the condition? When can we do that? Sometimes we cannot do that. Sometimes we cannot keep both I and j unchanged. But I want you to tell me that what is the condition for that? When can we change? When can we keep I and j both unchanged? Can you say that? What is the condition for that? Uh, 1972A, it's another problem. Maybe we can talk about it another time. Or also you can say that in the Telegram channel if you want. A sub j minus a sub I must be at most d. Not necessarily. Well, there are some values between I and j as well. These two must not have difference at most d. Each two consecutive numbers must be, their difference must be at most d. Exactly. Their difference must be at most I minus j times d. Their distance times d. Because, for example, assume that, for example, this is some k. This is k plus I minus j times d. This is possible. Why? Because you can just keep increasing values by d and everything will be correct. So what I say is that the condition, you can do this if and only if a sub I minus a sub j is at most their distance times d. For example, if you consider I minus 1, only if their value differs by at most d, I minus 1 can be the previous one that is remained unchanged. If their distance is 2, their difference must be at most 2d. If their distance is 3, their difference must be at most 3d, and so on. So basically, their difference must be their distance, at most their distance times d, such that it's possible to keep I and j both unchanged. Okay, do you agree with this condition? If you agree, please again use this emoji or put a plus in the chat. And if you want me to explain again, let me know. So basically, I'm saying that if I is the last one to be kept unchanged and j is the previous one, this is possible if and only if the difference of these numbers is at most their distance times d. Only in that case it's possible. Is it completely clear? If you have any questions about it, if anything is not clear about it, let me know. Okay, so I guess everyone are okay with that. So that's all. We define dp of I. Why? The reason is that, as I said, even if their difference is I minus j times d, you can just keep increasing numbers by d and everything will be okay. And if the difference is less than that, after some time you can just keep their number constant. So basically, I mean, even if the distance is I minus j times d, it's possible to assign numbers here such that the difference between each two consecutive is at most d. But if it is k plus I minus j times d plus 1, then there's no way. Then we can say that even by pigeonhole principle, we can say that there will be some numbers such that there will be two consecutive numbers such that their difference is greater than d. So basically that's the condition. And that's all. When we know this condition, we can just have a 4 for each I. We can have a 4 on all the previous j's if j and I were okay, or in other words, their difference was at most their distance times d. dp of I will be max equal to dp of j plus 1. And this way dp's can be calculated. And let me show you the code as well. The code is very simple too. Let me also show you the code. You can see my code here. basically, as I said, this was a minimax problem. So first of all, I did a binary search, and check of mid checks if the answer can be at most mid. Okay, if check of mid was true, high is equal to mid, we search in the less numbers, smaller numbers, otherwise we search in the larger numbers. And then the indents are very bad here, sorry for that, but let me talk about it. In this check of x, I want to see that if answer can be at most x. What I do is this: I have a for I from 0 to n. I first set dp of I equal to 1, because at the least case scenario, the answer is 1. I can only keep this one unchanged and change everything before it. And then I have a for on the previous j's if abs of a sub I minus a sub j is less than or equal to x times I minus j, dp of I will be maximum of dp of I and dp of j plus 1. This way all the dp's will be calculated. And the maximum number of unchanged elements is going to be the maximum of all these dp's, because dp of I is the case where I is the last one that is unchanged. So we can iterate on which element is going to be the last one that is kept unchanged, and just calculate the maximum of all these dp's. These are the different cases. dp of I means that the last one is I. So the maximum of all of them is gonna be the maximum number of unchanged elements. And if n minus ans was less than or equal to k, ans is the maximum number to be unchanged. So if n minus ans is the minimum number to change. If it was less than or equal to k, it will return true. Otherwise, it will return false. And that's all. So that's basically how a problem like this can be solved. Is it completely clear now? Is the solution completely okay? If it is, again, please use this emoji or put a plus in the chats. So basically, again, in this problem, what we faced with was first a minimax problem. So first of all, we said that, okay, let's do a binary search to see if the answer can be at most d. And then we said that dp of I, yes, sure. I said that dp of I is gonna be the maximum number of unchanged elements, the maximum number of unchanged elements to be kept. I said that, okay, let's have a for on the previous unchanged elements. See, this is I. I said that, okay, let's see that what is the previous one that is unchanged. Assume that it is j. What I said was this. I said that if this is I, what condition j should have such that j can be remained unchanged to similar to I? The condition that j must have is that the difference between ai and aj must be at most x times I minus j. Why? Because for each step that you can move forward, you can change your number by at most x. Every two consecutive numbers can differ by at most x. So if two numbers are at distance d, their difference must be at most d times x. For example, assume that the distance between I and j is 3. We know that each time that we go forward, we can change number by x. So it's like we can 3 times change our number by x. So in total, we can change number by 3x. So basically, that's why I say that I can see that what I minus j is, because each two consecutive numbers differ by x, if these numbers are at this distance, the difference must be at most x times this distance. Okay, it must be this distance times x. So if this was greater or equal to the real difference, it's possible to keep j before I. So dp of I will be max equal to dp of j plus 1. Okay, is it completely clear now? Venkat and other guys. In log of v, yes, it is, yes. It is n squared log of v, if v is the maximum of all the guys. Exactly, yes. We do not change some of things. Make a simple example to demonstrate that. Okay, let's see that if we have any good Yes, for example, let's consider this case. Assume that we are doing a binary. Assume that our D is 2. We want to check if the answer can be 2 or not. We'll start from the beginning. Let's calculate the DPs. Let's calculate the DPs starting from the beginning. What is going to be DP of 1? DP of 1 will be 1. The maximum number of unchanged elements will be 1. What is going to be DP of 2? Initially we set it equal to 1 because it can be remain unchanged alone. And then we have a 4 on all the previous ones. We see that if 1 can be before 2, because our D was equal to 2, 1 can be before 2. So it will be max equal to, it will be maximized with DP of 1 plus 1, which is going to be 2. Also for 3, it will be max equal to DP of 2 plus 1. So it will be 3, because 2 can be before 3. Their difference is at most 2, so that's okay. But when you come to 3, but when you come to 7, the point is when you come to 7, you cannot append it to any of the previous ones. None of these J's works except the first one. Why 3 won't work? Because the difference between 3 and 7 is 4. It's more than 2, so it won't work. Why 2 doesn't work? Because the difference between 2 and 7 is 5. So if this number in the middle is 3 or 4, its distance with 7 will be more than 2. If it's 5 or 6, its difference to 2 will be more than 2. But for 1 it works, because the distance between 1 and 7 is 3 and the difference is 6. So the distance times D is greater than or equal to their difference. So we can just keep increasing. If we can keep 1 unchanged and 7 unchanged and change this 2 to 3 and change this 3 to 5, then we have 1, 3, 5, 7. So it is possible. So DP of 7 will be 2. For 8 can be after 7, so its DP will be 3. 9 can be after 8, so its DP will be 4. And this is all the DPs. And we see that n minus the maximum DP, which is 4, n minus max DP is 6 minus 4, which is 2. It's greater than k. It's less than or equal to k, because k is 3. It's less than or equal to k, so it is possible to make the answer 2. Then we search in the smaller values. And we see that 1 is possible too. So the final answer is going to be 1. The problem that we're discussing is 360b. The maximum of I or j plus 1. How is updating work? Well, the point is that if j can be before I, if j can be the last element that is kept unchanged before I, dp of I can be dp of j plus 1, because we can see that how many is unchanged till j. Now we are keeping how many is unchanged till j, and now we are keeping I unchanged as well. So we are adding one more to that. So the number of unchanged values will be dp of j plus 1. Is it okay? But can we improve time complexity? Why can't we somehow what? Select j greedily. Well, greedily does not necessarily work. If you mean that we just keep the first one that is possible, it does not necessarily work, because maybe there's some other element before that such that its dp is greater, and we can append this to that one. Not necessarily the closest one has the greatest. Can I share drawing for this CP? You can upload it somewhere and put the link in the Telegram channel, I guess, because in here I think links cannot be shown. Or maybe put the spaces instead of dots between on your URL. Is it clear? As you can see this remote controller. Do you want to change the color of the background to make some difference? Are you in College Park? Yes, I'm in College Park. In CP. Can we use the longest increasing sequence here? LS. It's kind of similar to LIS, but it's not exactly that. If we wanted the difference between each two consecutive to be more than I minus j times d, it was possible to do LIS, but in here, not necessary. Yes, CP for sure. I even live in the CP city. My city is even CP. So, who's like that? Everything is CP. Let's change the color. Guys, which color do you prefer the most? Let's make some difference. Sure, Bami Dipati. Happy to help. Dark, which one is dark? None of them are dark. Only, even this one is not dark. None of them are dark. Because it's a light, so the dark one is to turn it off. I can turn it off. It's not that dark though, but I can just turn it off. That's also an option. Yeah, it was pink, so I was thinking of changing it. So just choose very quickly, and then we move on. This one seems good too. Is it good? Turn off is black and white. Yeah. Yellow. Okay, we have more yellow suggestion. We have more yellow ones. Okay. Good. Okay. So I kept it yellow because there are more yellow words. Okay, so shall we move on to the next problem? And guys, if you like the video and it won't be an issue for you, it won't bother you or anything, it's easy for you, I would appreciate it if you like the video. You can support me by doing that if you are okay with that and it doesn't make any hardness for you in any way. Thank you guys. It's 88 now, I should refresh it. I refreshed. 95 now, cool. Thanks for explaining. Please use test cases by explaining. It helps understand. I'm a beginner, so yes, sure. From now on, I try to also use test cases as well. It's 100 now. Thank you guys. We are exactly on 100. Thank you for supporting, guys. Okay, so let's move on to the next problem. And I guess that we cannot get to the last problem today, but I put it in the Codeforces group so that you can think about it and you can maybe solve it another time. So let me tell you the third problem, minimization. Minimization, it says that you've got array A consisting of n integers and a positive integer k. Array A is indexed by integers from 1 to n. You need to permute the array elements so that value ai minus the sum of these values ai minus a sub I plus k becomes minimal possible. And it is allowed not to change order of elements at all. So basically you want to just permute this array, just change their order such that this value will be minimized. Sigma of I from 1 to n minus k, ai minus ai plus k will be minimized. Let me write it here as well. So we have some n, which is up to 3 times 10 to the 5th, some k, which is at most minimum of 5,000, and n minus 1. And we have an array a1, a2 to an. We want to permute it, change the order of the elements. as we want. Change the order of the elements, swap them, and change the orders of the elements as we want, permute it any way we want, such that at the end, sigma of I from 1 to n minus k, ai minus a sub I plus k will be minimized. This looks a lot like the previous problem, although it's not minimax anymore. So if we wanted to minimize the maximum, again, we would think about the binary search idea. But here we want to see if we can do, we want to see that what we can do in here. If again we had a minimax problem, the first thing we could think about was doing binary search. Yeah, I sent the link. So how can we, okay, what can we do? Well, first of all, let's just look at the problem more clearly. This always is important, that when you face a problem, let's see that what is it exactly saying. Guys, if you look at it, you are trying to find the difference between a1 and a of k plus 1, and then the difference between a of k plus 1 and a of 2k plus 1, and then the difference between a of 2k plus 1 and 3k plus 1, and so on. Right? Also, you have the difference between a2 and a of k plus 2, a of k plus 2 and a of 2k plus 2, a of 2k plus 2 and a of 3k plus 2, and so on. And the same for a3, a of k plus 3, and so on. So it's like we have several chains, and these chains again are independent of each other. These chains are completely independent of each other. It's like we have one array that is a1, a plus k plus 1, a2, k plus 1, etc. One array that is a2, ak plus 2, a2, k plus 2, a3, k plus 2, etc. One array that is a3, ak plus 3, etc. So that's basically like this. There are some independent arrays, right? Calculates the 3 times 10 to the 5th factorial of our permutation and return the mean. That's a good solution. It's a bit slow though. Yeah. So first of all, guys, we find this independence. This helps us to look at the problem with a very clearer vision. Now we can see everything in a more clear way. Right? Do you guys agree with it so far? So basically, it's like we have several independent arrays, and in each array we want to find the difference, sum up the differences between consecutive numbers and sum all of these up and minimize the total value. We can sort the array. Yes, exactly. I will talk about that next. That's great. Exactly. Yes, the next thing that, yes, these arrays are the same modulo k. I mean, the indices that are same modulo k, they are going to be in the same array. Exactly. And now I say that basically what I have is that, as also Bamidipati said, it's the best to sort each array in an increasing order or decreasing order. I mean, having a valley like this is not good. Why? Because this way, for example, assume that this is a1, let's say x1, such that we don't confuse it with that, x3, x2. We have three values. x1 is less than x2, less than x3. If we do it this way, the value that will sum up is x3 minus x1 plus x3 minus x2. But if we put them this way, x1, x2, x3, the total sum of the differences between each two consecutive one will be x2 minus x1 plus x3 minus x2, which is x3 minus x1. x3 minus x1. Okay, so we have x3 minus x1. this way. And you can easily say that x3 minus x1 is the minimum value that we can achieve. So, I mean, basically, if we put them in increasing order or in decreasing order, the sum will be minimized. Okay, there's Blitzscope right now. I enjoy entertaining Blitzscope stream. Let's just open it and see that how is it going.
Like, except
oh, tourists is competing. I guess probably everyone should go there and watch how tourist is competing. It's tourist versus conqueror of tourist. It looks interesting. Tourist is conquering conqueror of tourist, basically. And how serious is tourist's face? Okay guys, so I guess you can all leave the stream right now and watch it later on. You can continue going there and watch. I will explain it again anyway. I will explain it anyway, but yeah. How to find the arrays so you can sort them? Yes, we'll talk about that. Very bad at mathematics. I had a math topic stream as well. Go to the topic. Guys, I extremely encourage you to watch all the topic streams and solve all the problems there. If you just come with me and solve the problems that I'm telling you and I'm explaining to you, you will almost see all the ideas that are necessary and you can easily improve your rating. So I strongly recommend you to watch all the topic streams and solve all the problems that is discussed there. I will make a problem set list for you as well. Put it in the Codeforces group. I will put it for you such that you can have additional training as well. But we will try to cover everything, every topic that you guys need. Python till and now I'm learning Java, so PCS. What should I do? Get to hackathon developing. Well, that's a different thing. But if you want to learn competitive programming, you have to do C++ if you want to do that. Yeah, I will continue. Yeah. So yeah, basically what we can say is that we can sort the elements and this will give us the minimum value. If we do that, if we sort the elements, we can say that the final answer that we get is going to be maximum of those values minus the minimum of those values. And that's the minimum value that we can get. Because anyway, you have this minimum value somewhere and this maximum value somewhere as well. And if you sum up the differences that we have in here, anyway, we should go from minimum to maximum. So we should cost at least this much max minus min. It's like we go up and down, but anyway, from minimum, we have gone to maximum. So we should have gone up this much anyway. So in total, our answer will be at least maximum and minimum. And if you put them in ascending order, you will get exactly maximum minus minimum. Is it clear? Yes, in future I will teach convex optimization as well. That's the next level. That's the harder level. Right now we are solving several 2000 DP problems in a way that is clear for everyone, even with 0 rating. So, is it clear, guys, that sorting in ascending order will work? Now I will talk about how to decide how to distribute the numbers to these chains. But the point that I'm saying that after distributing them, after this distribution, in each of these intervals you should sort them in an increasing order. Is it clear? If any part is not clear, let me know to explain it again. Okay, so now we know that how to distribute these numbers. Okay, we know that after distribution how to order the numbers in a single chain. Now I want to say that how to distribute them. Don't you think these problems are overrated? Well, I strongly believe that the solutions of these problems, I chose these problems in a way that their solutions are very easy to comprehend. And I'm trying to explain it in the best way such that it will be easier for everyone to understand. These problems only have ideas. They don't need you to like memorize some complex things, etc. And after teaching you more stuff, I will also solve harder problems that use more complex things as well. But I want to show you that how 2000 rated problems can be easily solved with the things that we know already. So anyway, now I have several chains, and as I said, they are independent, and the length of them is n over k, but some of them are floor of n over k, some of them are sailing of n over k. You can easily say that n modulo k of them have size n over k, k minus n modulo k of them have size n over k, floor of n over k. So n modulo k is sailing of n over k, k minus n modulo k of them is floor of n over k. And then I say that let's call this S1 size 1. We have, for example, K1 chains of size S1, K2 chains of size S2. The next thing that I say is that each of the chains, if I sort all the numbers in increasing order, each of these chains also form a consecutive interval in the order of the total numbers. If I sort all the numbers, each of these chains are a continuous interval in that. Why? Because I said that in each chain, I just want to sum up the maximum minus minimum. In each chain, I will sum up max minus min. Now look at the chain that the minimum number is in it. It's the best if all of them are in a prefix. This way max minus min will be minimized. So it's easy to see that when I'm adding up max minus min, it's like I want to split my array into K1 intervals of size S1 and K2 intervals of size S2. Okay, I want to split it into K1 intervals of size S1 and K2 intervals of size S2, and in each of them I want to add up max minus min, maximum minus minimum. In each one of them I want to add up the value of maximum minus minimum such that the total sum of all of these will be minimized. Yes, put exactly. I want to put, in the index that the minimum number is, I will put the minimum numbers. Could you explain the transition from chains to floor and sail? Yes. So basically I'm saying, what problem was that? Let me send the link. This problem is minimization, 571b. I said that if you take a look at these chains, we have k chains, right? We have k chains. Each of them have size n over k, but either sailing of n over k or floor of n over k. So I want to see that what is their sizes. Their sizes is either floor of n over k or sailing of n over k. And then I'm saying that n modulo k of them have size sailing of n over k, k minus n modulo k of them have size floor of n over k. And then I'm saying that, so is it clear? Is it clear what K1, S1, K2, and S2 are? What floor and sailings are, Roman? Awesome. So now I'm saying that to each chain, I will assign a consecutive interval of numbers, because I know that in each chain, I simply add up maximum minus minimum. In each of them, maximum minus minimum matters. Because I said that I will sort them in increasing order and I add up maximum minus minimum. So it's better if I have them as continuous segments. So my problem can be reduced to this. I can say that, but each time I either choose an interval of size S1 or I choose an interval of size S2. In total, I should have K1 intervals of size S1, K2 intervals of size S2. So now, what do you think we can have as the definition of our DP? At the end, I should have several slices such that I will have K1 slices of size S1 and K2 slices of size S2. How do you think we can split them? Waiting for solo leveling, the site is down. First n modulo k have, exactly, first n modulo k have sale of n over k, remaining have flower of n over k, exactly. Bamidipati. Anonymous, does anyone know anime streaming sites? Many of CPers are into animes, so it's possible that they know. I haven't watched good animes. You can suggest me good animes. I recently watched Blue Eye Samurai, but not recently though. It's 6 months ago, more than 6 months, and it was really good. Although it was not anime, it was more like cartoon, but it was, the story was in Japan and it was cool. If you had good animes anyway, you can recommend here. Death Note, Attack on Titans, Mandalorian. Mandalorian is not an anime though, but I remember I watched some episodes of that. And Death Note and Attack on Titans, many people recommended that to me. Probably I should watch them. DP is CNT of K1 sizes. Okay, what else? How many dimensions do you think our DP can have? Case closed. Bollywood movies. I've seen several very good Bollywood movies. I forgot the name of one of them, but I've seen 3 or 4 Bollywood movies and they were really great. I really liked them. It was not like I was thinking. I mean, they were way higher than my expectations. I mean, they were really good. If you have any Bollywood movies to suggest, definitely suggest that too. I will watch that and we can talk about it in the next stream. Slumdog Millionaire. Guys, at the same time that you're suggesting DPs, I'm opening this. So this is dimension count of K1 is in dimension I guess. Yes, that's very good. And what is J? What do you think J can be? Tombat. I will take a look at them. There were some Bollywood movies that they really had some deeper meanings about society, etc. And that was really interesting. How to improve DP? I said it so many times. I strongly recommend you to watch all the topic streams that I had, especially on DP. I had 5 topic streams so far. Watch them and solve all the problems. I will definitely add some problem sets, some of the best DP problems as well in a problem set, and I will set this. I will have them in Codeforces Group, and I believe that if you come with me and just solve all the problems that I'm telling you in the topic streams, you will learn a lot, and then you can start practicing as well, and definitely your skills will improve. Yeah, I don't know. Cool. Any advices for newbie? There are many advices for newbies that I've had in my channel. If you go to my channel, you can see these guideline videos. This video is very close to 40k views. It's exactly 39. Maybe today it gets to 40k. But anyway, especially all of these are for newbies. This one is also for pupils and specialists as well. If you're a newbie, I recommend you to watch all of them. If you're a pupil or a specialist, I recommend you to watch this one. Okay, so guys, let's get back to the solution because I think I made you so much distracted. So let's say that we have dp of, as you said, for I, it can be that how many subsegments did we have such that the length was S1, and J is how many intervals that we had such that their size was S2. And all of these, how many elements do we have in total if we have I of size S1 and J of size S2? It means that we have I times S1 plus J times S2. J times S2 elements. Out of this prefix of size I times S1 plus J times S2, the good news is that we don't need to keep the length. We can just keep I and J, and the length will be determined based on I and J. The length will be I times S1 plus J times S2. And I and J are both up to K, and K is up to 5,000, so it's good. And then we should decide if we want the next segment to be of length S1 or of length S2. So either we will go to dp of I plus 1 and J, or I and J plus 1. If I is less than K1 and if J is less than K2. I mean, we can add them only if their corresponding value is less than the S limit. And then we can easily update that dp, and we can just say that we add max minus min and we go to that dp. And this way, easily by having dp of I and J, these values can be calculated. Let me show you the code as well for this problem. I don't know why I accepted it twice. Anyway, so if you take a look at this, basically what I'm doing is this. I have all the elements, I sort them. If k is greater or equal to n, the answer is 0, definitely. What I do is this. First of all, I just set the answer to be the sum of all the differences. So I just first set the answer as the maximum minus minimum, first of all. And basically what I did, I had a small twist with the solution I told you. I said that instead of adding these maximum minus minimums, only subtract these values, these bridge values. These bridge values are the only values that we are skipping to adding them. Because basically we are adding the difference of each two consecutive values. Only for these bridge values we are not adding them. So basically I'm just in here adding those bridge values. So I say that if I times t1 plus j times t2 was greater than n continue, I have a for I up to k and j up to k. T1 is n over k, T2 is n over k plus 1, and NE1 is n modulo k, NE2 is k minus NE1. And I just go from dp of I and j to dp of I plus 1 and j and I and j plus 1. Or in other words, I update dp of I and j from dp of I minus 1 and j and dp of I and j minus 1. And then I will just see that where is my bridge, and I add this value of this bridge to it, and I will decrease it from my final answer. I could instead, as I told you here, just sum up the maximum minus minimum of this interval. Both works. Anyway, the main idea is to define dp of I and j. The rest is just how do you want to update this dp. The main idea is to look at the problem like this, that the chains are independent and each of them have some size. We have k1 chains of size s1, k2 chains of size s2, such that the sum of maximum minus minimums will be minimized. Yes, I could pin the link. I didn't know that so many people are gonna ask that, so let me now pin it. One CM video also, please. Sure. First time to your channel, subscribe. Great, very welcome. I'm pretty sure that you can learn a lot. Left watching Bollywood movies, web series, only do CP and anime and math since some years. Cool. Iga movie is an old movie, but very entertaining. Iga. Cool. These are science fiction stuff, right? They're sci-fi. Could you share? Okay. Do you think that if someone has 130 IQ, then the person can become a red color, or is more intelligent? I think, Omnic has a sentence that he says everyone can become a grandmaster. So you can watch my interview with Omnic as well if you want. It's interesting. If you want, you can take a look at that. Yes, definitely, if someone has IQ 130, can reach Grandmaster, reach Red Color. Do you know any resources to learn math, especially for CP? I had a topic stream for math. I highly, as always, again, I say that watch the topic streams and come with me. You will definitely learn that. Learn everything that is needed. For books, I will recommend Mathematical Circles, Russian Experience, if you want a book. And also solve a lot of problems from Codeforces. That's also super helpful if you do that. How can we measure IQ? I'm not sure. There are some tests online, but there are, they're not necessarily really give you your IQ. But the idea is not that much clear. Okay. Yes. So basically what I was saying is that previously, what did I say? I said that we have several chains, and in these chains, I will add up max minus min in each of the chains, right? And I want the sum of these max minus mins. What I say is that this max minus means, it's like the numbers are sorted. So it's like you're adding up this, plus adding up this, plus adding up this, and this. So basically, you can look at it another way. The bridge idea was this. I can say that it's the total sum, the total max minus min, minus these values that we are not adding them. So basically, when you are adding this value minus this value, plus this value minus this value, plus this value minus this value, plus this value minus this value, it's like the last value minus the first value, the total maximum minus the total minimum. Only from that you should subtract some values. These differences must be subtracted from that. Only these differences must be subtracted from that. Why? Because basically, if you take a look at it, this max minus means that you're adding them up. It's like we are just skipping some of the parts. These are the bridge that I was telling you. It's like we are not adding here. For example, if this is 1, this is 5, this is 7, this is 10, we have basically 10 minus 1. Only 7 minus 5 is, it's like we jumped from 5 to 7. And we do not spend the cost from 5 to 7. That was the bridge idea. And that was why I said that. You could also calculate the total max. Only these values that you are skipping, you just skip them. This was also possible. But you could also add up max minus mins. That they both work. Is it clear? Can you type the book names? I typed it once before. I type it right once again. Mathematical Circles, Russian Experience. Let me pin this one now. Can you give the problem set? Yes, sure. I will definitely make a problem set for you guys. Sure. I even attended one during school. Cool. You were from Ukraine, Roman, right? Yes, sure, I will. Let me also tell you an example. So assume that your numbers are like this, 1, 3. We sort the numbers, so they will be like this. And assume that you have sliced them like this. Slice them like this. So you are basically adding max minus min from each one of them. So in here you have 4 minus 1, which is 3. In here you have 11 minus 6, which is 5. And here you have 20 minus 15, which is 5. And you're adding these values up. What is the sum of these values? It's 13, right? I said that it's like initial, see that what is the cost to go from 1 to 20, or in other words, what is 20 minus 1? 20 minus 1 is 19. Only from this 19, you can just subtract this 4 to 6, which is 2. And subtract this 11 to 15, which is 4. And this is going to be 19 minus 6, which is 13 again. Why? Because you are going from 1 to 4, and then you're going from 6 to 11, and then you're going from 15 to 20. You're adding these values up. This is 5, this is 5, this is 3. You could also initially just add from 1 to 20, which is 19. Only from it subtract this 11 to 15, which is 4, and this 4 to 6, which is 2. So basically I'm saying that if you just added these values as well, you could have the total max minus min. So you can just keep total max and just subtract these values. This is not that important. This is just another way to look at it, but it's not important. You could also, in your DP, each time when you add another slice, you could just add max minus min in that one. Is it completely clear now? Born in Russia, lived in Armenia, studying in Cyprus. Cool. That's very cool. I thought you were from Ukraine. Cool. So you attended a mathematical circle. Very cool. Unfortunately, the fourth problem, we cannot discuss it today because our time is up, and I planned this stream for 2 hours and it's now 2 hours and I should leave very soon, unfortunately. I wish I could solve the last problem as well, but I put it in the group. Yeah, the question, I shared it before. I will share it again. It's this one. And this could really this problem was less dynamic programming. It's more like other ideas, but it has some mellow dynamic programming in it as well, some mild dynamic programming. The 3 problems that I discussed were more dynamic programming. I will go and code instead of watching him, or do both. No problem. This stream is very nice. Thank you very much. Great. Awesome. Did you guys completely understand the solution to all the problems? Yes, it's better to turn the tags off on Codeforces. If the tags were open for me, it was because I solved the problems. I don't remember if I turned it on at all or not, because I'm not practicing much on Codeforces anymore. But when I was practicing, I would definitely turn the tags off. Can you divide and conquer next? Yeah, sure. I put it in the votes. I put all of this in the votes, and I will just do whatever most of you guys say. Let me put the link to the Telegram channel here as well again. You can join there, and I put the vote there. You can just decide together that which topic do you want me to discuss. I have an ID PC tomorrow. I know that it's some regional ICPC. I wish you good luck. I hope that it goes well for you, Sabir. Where are you from, Sabir? I want to know that which region is it? Bangladesh. Cool. Awesome. I hope that it goes well. Okay, guys. I hope that you completely understood that. I promised you that even if you are a newbie, you will understand. You will completely understand the solution to these 2000 rated DP problems. This was my promise. Did this happen? Always 60 before. No, our previous topic streams were different. Previously, we had combinatorics, before that greedy, before that another thing. Yeah, I see. So, happened. Awesome. Awesome. Cool. Cool. Again, guys, if you want and you're okay with that, I would appreciate it if you like the video. It can help me. If you want to do that, I would appreciate your support. Combinometrics, yeah. They chose combinometrics previously, and we discussed it, even though I didn't know what combinometrics is, but we discussed it because in the votes that was chosen. Okay, so thank you guys again. It was nice to see you here. I hope that this topic stream was useful for you and you learned a lot in it. Make sure to accept all these problems that we're discussing here, because it's gonna be super helpful. Blitzcup. Let's just go and watch the rest of the Blitzcup. I think you can do that. I have to go to attend the meeting. Yes, maybe they get lesser views than they deserve. If you want, you can share it with your friends. I think that would I would be happier if more and more people see these streams and it helps more people. If you know any friends who might get benefit from these videos, definitely share these videos with them as well. I can choose a cooking topic. Yes, you can choose a cooking and we will cook in the next topic stream. Yeah, you have all these options. I'm pretty sure if I put cooking as one of the options for the poll, everyone will select that. Okay. Thank you guys again. Soon there is a Codeforces contest. 2 days from now, I will see you there as well. So, goodbye for now.